When it comes to computer networking, I've always tried to draw this analogy to help explain it to folks like a little bit more of a physical and real world tie-in, right? Say an IP address could be the address, like a physical street address for a house or a building. And that computer at that IP address is that computer. It's that device, it's that host, it's that endpoint. And that is the IP address, while the ports for a computer may very well be the doors or the windows for that home or that building. And you could interact with services and network opportunities to get to poke at and maybe get your entryway into that building, or right with and through these doors and windows. But there's some other super cool and interesting things you can do with these doors and windows on these buildings and hosts. And maybe that's redirecting or port bending between different hosts and computers. In this video, we're going to play with it and we'll see what damage we can do with some Linux hosts with port bending. Before we dive into the video, here's a quick note from today's sponsor. Hack the Box is happy to announce and introduce their latest training path and certification, the Certified Penetration Testing Specialist, or CPTS. CPTS is a hands-on certification that tests your skills in penetration testing, ethical hacking, compromising endpoints, and delivering a professional, commercial-grade report. It's not just pulling public exploits off the shelf or finding typical CVEs. CPTS puts you in the driver's seat to hunt down security issues, prove your merit, and chain together multiple vulnerabilities to demonstrate the maximum impact of an exploit. You'll exploit web applications for initial access and pivot to move laterally through an Active Directory domain, escalate your privileges, and perform post-exploitation on both Windows and Linux targets. Take the exam and write a professional pen testing report to prove you have what it takes to help organizations take action and remediate vulnerabilities. Get credentialed as a Hack the Box certified penetration testing specialist and demonstrate your security expertise. Jump into the action by cruising through the penetration tester job role path on Hack the Box Academy. Grab an exam voucher, take the test, and earn your CPTS that never expires. You can dive in right now with my link below in the video description. Huge thanks to Hack the Box for sponsoring this video. Alrighty, so first things first, credit where credit is due. I'm going to be poking around and playing in my Kali Linux virtual machine right now, but I do want to give the shout out and kudos to the super fine folks and smart fellas out on the internet, on the Twitterverse in this case, and this is Mike Taggart. You might have seen him around, kicking around, doing great stuff with the Taggart Institute, and sometime back in September, he had asked, hey, Red Team Ninjas, is it even possible to port bend local host traffic? Like, can I redirect traffic destined from my internal local IP address 127.0.0.1 on any port XXXX and bound it towards 127.0.0.0 to go to another port, right? Like ZZZZZ, who knows? And it's hard to do that on Windows. Actually, let me draw a little disclaimer, an asterisk there. I believe this is totally possible to do on Windows. I'll have to go dig into some of my notes. I'm thinking that I have seen the syntax and the method to do that. But in this video, I do want to showcase it on Linux. And the real kudos goes to Graham. Graham Helton is another super sweet fella out and about there. And he's saying, hey, I don't know the Windows trick right off the top of my head, but this can be done with IP tables, the firewall in Linux. You can use some syntax, some of the arguments and parameters here, and I always get these wrong. I never remember the switches and flags and arguments that you can pass to IP tables. So forgive me, I am going to reference these and probably Google around a little bit, but I think there's some cool stuff that you might do here because you can use IP tables specifying the NAT type or whatever and saying, oh, for pre-routing, you could specify the protocol TCP when there is a destination port for traffic. Like say, oh, you are sending packets and you're trying to connect to port LEET or 1337. If you were to redirect that port to ports 8080, it may very well go there. You could just bounce and pivot and bend the port to some other destination port. Ultimately, you'll need another rule to be able to cement this, and you'll use that output flag. Specifying that, I think that's TAC I. I can never tell with TAC L. This font is killing me here. And then you'll end up specifying, hey, on localhost as your sort of interface here, LO, that destination port 1337, we will redirect that to ports 8080. So let's play with that. Let me showcase it here. I want to see if I can do this. I want to go open up a terminal here, and I'll split the window, because what I want to do is I want to use a couple netcat shells. Let me go ahead and start up a netcat listener LNVP to listen without DNS resolution with N as that flag there, verbose, so we can know when we have a connection and when we're waiting. And the port will go that 1337, correct? Perfect. That's super simple. That's super small. What if I were to then try to connect to that listening socket or port? We'll go ahead and netcat into our host internally 127001, and we'll connect to 1337. There we go. We get our connection, as you can see that there. Super small, super easy, as you would expect from a netcat session, right? We'll slap in our please subscribe notion here, if I spelled that right. Oh my gosh, escape sequences are killing me. I added an extra PL because I was testing that above. Anyway, what might we be able to do to redirect that port? Let me use that syntax. Let me use IP tables, tac T, nat, and I want to say tac L there, pre-routing, tac P for the protocol TCP. When the destination port is 1337, we'll use the redirect option here and bring that to ports 8080. Yeah? Now, obviously, this is going to complain. It looks like it's going to need tac I here. And I have a hunch this will fail because it was actually still upset about the destination port. Is that with a single tac? What? And that is actually complaining about tac D port, but I have a hunch that might just be because we are not running this as root. So we'll need to specify that with that sudo command prefix. I'll enter my password here for Kali, and that worked. Theoretically, there's no output, so that command, I believe, succeeded. If I wanted to check out the exit status or the return code, we could check out $sign to denote a variable and the question mark for indicating that 0 is the successful return code. So that worked without an issue, and we'll do that exact same thing for the second command. We'll use sudo as the prefix here, tnat tac capital I output, specify tac P for that protocol TCP, and denote my outputs, or I don't know why O is the argument there. I might be not realizing or thinking straight, but LO for our localhost interface. And we'll use that destination port 1337 to redirect to ports 8080. There we go. That seemed to have succeeded. So what I'm going to do now is fire up that same netcat listener of 1337. There's that port or that door or window that I'm opening up here, but I'll try to go ahead and connect to that just as I did previously. I'm going to use netcat 127001 and connect to port 1337, but its connection refused. But I am listening on that port. But we just set up that port bending rule for local traffic so that we were able to go ahead and actually bring that over and bounce it towards port 8080. So let me start up a netcat listener and that other tab saying, hey, let's listen on 8080. And while we're listening on 1337, it doesn't even matter if we are or if we aren't. Here, I'll try to send this super quick. Let me try and connect to that 127.133.7 port. But it brings me to 8080 because of that port bending rule. Now, again, it doesn't even matter if this section is open. If 1337 is listening or not, we know that we are going to get bounced and redirected to 8080. Let me show you that. Not running the 1337 service, but I'm going straight to 8080. Didn't even need that other netcat listener. Kind of slick, kind of cool, kind of neat. Now, here's a peculiar thing, though. What is my current IP address? What is this host? Looks like I am 111.138. So could I do something a little bit wonky? Could I try to connect to this from another instance? Say I fire up my little netcat listener and I have another machine ready and waiting for me here. I'm going to pull up an Ubuntu virtual machine. We'll start that netcat listener on 8080. I'll move this fella. And let me try to netcat to 192.168.111.138 on a 1337. That gets the connection. kind of neat, because even that was just bouncing from the port to a local interface. So there's some peculiar stuff you could do here. This is at least port bending to a local port, but could there be more that we could do here? Could we even in some way bounce one connection and one port traffic that's destined for some destination to a whole nother destination? Could we go from not just the building or home of the computer and host that we're in, but bring packages that might be delivered to the door of that, packets and other connections, to an entirely different building? Can we go to a different host with port bending? And yes, we can. And that's wild and crazy cool. So let's experiment with that. Let me play with that. I want to showcase this, but I want to draw some attention here to the fact that the syntax that we were using with IP tables in this example, with local connections, with LO being our local host interface here, the redirect flag that we're using is what allows that to go to local connections. Let me show you this a little bit more. I tried to Google around and see if I could kind of capture this. And do I have that? Yeah, I do. I wanted to grab some other notes here to showcase this. I was Googling around and seeing what other mischief could we get into with IP tables. Now, again, I don't know the syntax. I'm bad at IP tables. I have to look up literally everything. And even then I'm confused. I don't know what I'm doing. There are way too many flags and switches. But this question that was trying to ask and understand, hey, if I'm going to be bending things or trying to redirect traffic from one location to another, can I redirect that to a whole other host? And they say, listen up. Let me tell you, my friend, the redirect parameter, that flag and option here, alters the destination IP address to send to this machine itself. In other words, locally generated packets are then mapped to 127.0.0.1 address. It's for redirecting local packets. If you want to redirect the traffic between services on this computer, on the local machine, that's the best choice. But if you want packets destined outside of the system to go to another host or destination, you want to use DNAT for network address translation and some other things you might be able to do. It is the better choice of the two, as redirect will not work. So I found this other resource, and this is one that I think is kind of neat. It gets a little bit more nerdy. It gets into a little bit more of the whole conversation here on what you might be able to do with some of that port bending or port forwarding, depending on the vernacular that you particularly want to use here. And they offer some sweet examples of, hey, port forwarding between gateways or other intermediary devices. Again, using IP tables, of course, but it does something kind of slick. After it goes through some of this explanation, they showcase what you might be able to do with the router or firewall that could forward connections or bend ports to an entirely different device. I'm zooming in and out and I'm making a mess here, but if you use the syntax with pre-routing and then forward, with DNAT being the notion here, you could pivot it to a completely different device or completely different endpoint. So let me do something wild. Let me say I had another machine rocking and ready for us. I'm going to pull up a whole nother Kali virtual machine, and I'll put this one away for the time being. Let's say this virtual machine, this host was something that we wanted to explore with and play with, and say we, as a threat actor, adversary, or hacker, or whatever red team putting on your hacker hat you want here, let's say you compromised this device. Maybe you're playing a whole capture the flag thing. I don't know. You're doing some attack and defense. And actually, let me, if I may, add a notion here. This technique, if you're doing some like service-based game based off of network uptime and sustainability, or even like a King of the Hill capture the flag style, where if a service checker is looking for your team's flag on one device or in the others to determine whether or not you've compromised others and you are scoring because you've compromised that endpoint, your score might increase because, oh, you can plant your flag on different computers. But what if you compromise a device and you had some super sneaky, stealthy backdoor that does this port bending, and even if the real team, the players that are trying to defend their attacked service, keep their flag in place, what if you redirect the score checker to end up, hey, having traffic that goes to the victim or the opponent's computer redirect back to yours. So it always sees your flag and you always get points. That is a very, very, very dirty trick. And it's a little bit of, I don't know, maybe bad sportsmanship. And maybe I'm going to get my hand slapped for sharing some of these dirty secrets with some of those port bending shenanigans you might be able to do. But I did want to bring that as a scenario for you, and a sneaky, snarky thing you might be able to do in those games with port bending just like this. Anyway, I'm sorry for rambling. Let's get back to it. So say we had this other machine. Say we had this victim target computer that we were going to end up having redirected traffic sent to a whole nother host. Now, the way we have to do that is a little bit different. There are some other steps that we have to do because it basically means forwarding traffic or redirecting it to a whole nother device. And that has to be enabled. That has to be put together and actually in action here. What you should do is toggle this proc system settings here, and that whether or not you will forward IP packets. You'll need to run this as root, right? If you wanted to actually check out the current configuration of that file, you can just simply cat out that file. Right now it is 0, but of course we will need to run this as root because this is going to be a system privileged command, right? Let me go ahead and ls-tech-l that, and you'll see that is owned by root there. So we will need to go ahead and run with sudo, and let's slap in that echo 1 in that current file here. And now that is enabled, and this device should theoretically be able to forward packets, but it is worthwhile trying to bounce or toggle network capability. You have to be a little bit careful in this, right? Because, if it's something that you're compromising, you don't want to lock yourself out for whatever means, but we could try, service networking restart, fingers crossed. Seems a-okay. Haven't seen any errors yet. Maybe nothing's whining. Let's give it a go. I'm going to end up trying to now redirect traffic. This article chats a little bit about the syntax that we can use to redirect or bend or forward, whatever terminology you want to use, sending traffic to that other device, that other host, that other building. And we could say, okay, if we're redirecting traffic that our server receives, this current machine, through port 110 or whatever, port 80, port 1337, port quad 5 or quad 9, maybe whatever you're doing for like service checking in that CTF example, right? Say you wanted to kick it over to a different server to receive on the same port or a different port, you can do that with this syntax. You use IP tables, tac-tnat, A, pre-routing, P, the protocol destination port, DNAT to that destination, etc., etc. So let's try it out. Let me see if I could do this. Let's say I am going to use that IP tables, tac-tnat, tac capital A pre-routing, tac P for the protocol, we'll use TCP. The destination port, well, this is what port we are receiving traffic on. That was 110 in their example, right? And we could use whatever, quad 5. Let's say that the service checker was trying to see if we had a custom service up and available that was hosting our flag on port quad 5. And now we'll go ahead and use that DNAT specific argument to say, hey, we're going to use network address translation, bring this to another host on that network. Let's go ahead and bring that to the destination of the other host we want to bring this to. And if you remember that other previous server, this was the 192.168.111.138 machine. So let's check that out. Let's go ahead and bring this to that 192.168.111.138 machine on port 8080, as that was what we were using to collect our connections previously. That works seemingly a-okay and just fine for us. So I don't know, how do we put this to the test now? Well, let's say that our victim machine, the one that we've compromised and now maybe bent and forwarded some of the traffic to port 555, will now bring us over to port 8080 on the other left-hand host. So let me start up a Netcat listener on that port 8080, and let's have a third-party machine try to connect to the right-hand host. That is what? Their IP address is 145. So say this Ubuntu host is the system service checker. And let's try our darndest to connect to 192.168.111.145 on that port 5555. Now, I don't have that service running over here. But to be honest, hey, I suppose we can start it up. Like, there's nothing wrong with that. It's going to get bent and forwarded to the other host. So you won't see it show up over here on the left, or excuse me, over here on the right, but you will see it pop open on the left. 145, going to be bounced and redirected to 138. Let's try it out. Why? What am I doing wrong? Not seeing the connection just yet, so maybe I'm missing something. Let's see if we could try to masquerade what we end up doing for packets that could theoretically go to some other location. I believe what we could do there is IP tables, TAC-T NAT, and then capital A post routing. If you use TAC-J, we could specify masquerade. And let's see if that works any better for us. Again, I'm going to just, for sanity check, restart the networking service, and then I'll start to listen on Quad 5. And now let's try and connect one more time. Ooh, there it is. Cool. So as another reminder, say that this far left host is our HQ. It's our attacker machine. It's what we are using to host our own services and have things that we want to be able to, I don't know, have data sent back to. And this other right-hand host is doing its own thing. It's hosting its own services, but maybe we wanted to trick some other hosts or redirect it to another different location when traffic is sent to one port on this host. So we'll compromise this. We'll take advantage of it. We'll fully exploit it. We'll gain system or root privileges, and then we can fire off those couple commands where we set up the pre-routing so it forwards to another location, and then masquerade some of that post-routing there. And that, oh, it's not going to worry about messages or IP addresses that get sent to some different location with different corresponding IP addresses. Whatever the case may be, hey, we can cruise through with it. And then finally, that third-party host, maybe the service checker, could end up doing whatever it really wanted to, sending it over to the left-hand side host, even if it thought it was destinationed for that right-hand host. That is port bending. That is port forwarding. I might be getting these terminology things mixed up a little bit, but my goodness, I think that's kind of neat and kind of cool, and some sneaky thing you might be able to pull off in some scenarios. So there, we've showcased how we could pivot and twist and do different things with local only traffic, from, hey, connections to one port on one host going to a different port on that same host, but also, trying to take connections to one port on one host and bring it to another port on a different host. And that is kind of slick. Maybe you compromise something, you're able to do some damage, and I don't know, just change the way that the network behaves around you and have it do your bidding. Again, all reliant on compromising that other machine and having the privileges and permissions to set up those rules and some of that forwarding with IP tables. But I hope that's kind of neat. I hope that's kind of cool. I hope that's, again, paralleling it to that real world example that maybe hopefully you can use to explain to folks, hey, IP addresses, it's like a physical address for a home, a house, or a building. These ports, those are the doors and windows that you might be able to knock on, or, hey, maybe see if you can gain access to that building. But what if we did some weird and wild stuff where, packages destined for one location going to the doorstep of one place can be sent to another, and that compromised host or that whatever building in the middle is none the wiser. Thanks so much for watching, everybody. I know this was a little bit of a long one, but I hope it was kind of cool. And with that, I'll see you in the next video. Please do those YouTube algorithm things, like, comment, subscribe. You know the drill. Patreon and PayPal in the description. I've been recording and talking for way too long, and I'll see you in the next video, everybody.